we will begin. So if you take a look here at this idea of multiplicity, this was one of those things that we need to be familiar with in terms of our roots. It's basically telling us how many times a root, a specific root occurs within that polynomial, and because that is going to affect what happens at that location at the x-axis. All right. If you have a multiplicity of a 0 is an odd number, it will cross the axis at that number. So if it's odd multiplicity, it will cross the x-axis. However, if the multiplicity is even, it will only touch the x-axis, right? Which I feel like it's a little blurry up there on the screen. Maybe it's just going to be clean my board. But hopefully you're able to follow along with that. Maybe I'll put that over here to the side so we can reference that throughout. Axis. And even multiplicity is just going to touch the x-axis. Okay, so for any of the distinct roots that we looked at, they could have odd or even multiplicity. Basically, I have some examples here that we can help understand that idea. So this table goes through a bunch of these different things. If you take a look, if your factor is just x plus 3, remember we can quickly solve that if we needed to, but hopefully at this point we can say, oh yeah, I would set that equal to 0. I would subtract 3 from both sides. I get my root at -3. Hopefully you can draw the connection between these two almost immediately at this point. I hope. Right? So that root has a power of 1, or an exponent of 1. So that tells me the multiplicity is odd. And so it is just going to cross the x-axis or pass through the x-axis. Okay? So it gives you an example over there to the right. However, if we keep continuing through here, we get another one that's odd multiplicity. All right, it has an exponent of 3. Obviously, 3 is odd. That root occurs at 1. Remember, we could do like we did up here, but hopefully we're drawing the connection between the factor and the root relatively quickly. And so this is going to still pass through at that root. And you can see here it says the higher the odd degree, the flatter the squiggle. Okay? So it's passing through the x-axis at 1, but because it has a degree 3, it's going to kind of do this, like pass through and then continue on upward. It still is only intersecting the x-axis at that one point. It's just the higher the degree, the higher the odd degree, the flatter it's going to be. It's not ever going to continue like left to right on the x-axis, it's still only touching it at one location. Even though it might not look like it, it's only one spot, but it's going to pass through. Right? This guy, x squared. Sometimes we forget. Really, really, this is like x minus 0 squared or x plus 0. Which sometimes we forget about that. When it doesn't necessarily look like it, it should be one of those easy ones, but sometimes it's like so easy that we forget. So drawing the connection between these two hopefully is going to take place, but we get a multiplicity of 2. So it's just going to touch the x-axis. So, also remembering here, our degree is an even degree, and so the end behavior, both ends would go in the same direction. But not going to pass through. The multiplicity is 2. It's an even multiplicity. It's just going to touch the x-axis. It doesn't ever cross through at that root. And then kind of similarly there, we have multiplicity of 4. That root has a multiplicity of 4. And like it said up there above, the higher the even degree, the flatter the bounce. Okay, so you can see here, it's still just going to intersect at one location there, but it's going to make it a flatter intersection. It's not touching the x-axis at several consecutive spots there, just one, but it's going to make it flat. Okay, so that's the basic gist. But remembering that part there that's in the yellow box is important. Odd multiplicity passes through. Even multiplicity only touches. And so here we're still continuing to build our thoughts about what these higher degree polynomials are going to look like. We developed that, hopefully developed that understanding of the end behavior, what the ends look like. We talked about how to find the roots where it crosses the x-axis. We can get a better idea of what's happening in between the ends now that we know more about what happens at these roots. So if you take a look then at slide number 29, obviously this is coming from Khan Academy. So let's check this out. So unfortunately I couldn't get all of the answer choices in this screenshot, or I forgot to, I'm not sure. But if you take a look here, it says what could be the equation of P. So let's take a look. I have those roots marked on my graph, right? And hopefully we can quickly say, well, this would be a factor of x plus 2 to get a root at -2. And likely you could say, we could do x minus 0 or x plus 0, but we really don't need that there. Okay, but let's talk about like what the exponent might possibly be. Okay, so at this root in particular, that just touches the x-axis. All right, and so what I need to think through in my head then is that it's got to have and even multiplicity. All right, and like I said, I cut off the answer choices. So this exponent up here, this will have to be an even number. So it could be an x plus 2 squared. That's right over here. It could be an x plus 2 to the fourth or an x plus 2 to the sixth. But remember, you know, the wider that it gets there where it touches, the higher the degree. And then over here at this root, you know, this passes through the x-axis. And so you would have to have like a over here, an odd multiplicity. All right, so maybe I want to make this like an x to the third. But remember, as long as it was an odd number, 1, 5, 7, 9, etc., that would work. So if I was piecing these things together, you know, like I said, I intentionally or not, I don't remember. You know, my equation could look something like this. Okay, it wouldn't have to be exactly as that, but the focus here that I want you to look at is those exponents, knowing if it's got to be an even exponent or an odd exponent at those roots. Right? So hopefully that will help you out now with that final Khan Academy assignment. That's due later on this week if you haven't tried that already. So I have two distinct roots, one of those at -2 and one of those at 0. And those would help me with my factors. All right, so questions on that? All right. So I also gave you 5 points here in Get More Maths today. Practice it with 5 points. Because we'll wrap up here shortly. And then you have plenty of time to work on both the Khan Academy assignments and the Get More Maths assignment. Notice how it says distinct, you know, specific, unique. So it has one distinct real 0. Okay? It says what is the 0? Just so you know how to answer this, we want to basically say, well, that 0 would be at -6. Okay? The long and short of this, technically, let's set the factor equal to 0. You know, subtract 6 from both sides, there you get x equals -6. That root there at -6 would have a multiplicity of 3. So it would cross through the x-axis at -6. But when it says, what is the 0? It's not asking you about multiplicity, it's asking you about the 0. Down here, though, in the second part, it says, what is the multiplicity? That's where you put 3. Okay? So I think those should be pretty simple, but you gotta know the terminology, know what it's asking, and sometimes that's the tricky part more than anything. Rather than answering the question, it's just saying, oh, what is it saying? So that's one type that you'll see in that set. Here today you get more math. If the degree of p of x is 8, what is the value of b below the degree? So this would technically be multiplied together, like a couple terms multiplied together. So I would want to add these guys together to get the degree of that term that's multiplied together. And so if the degree is 8, I'd have to have b equaling 1 to add up to 8. If this was like x to the 4th plus x minus 5 to the b plus, that would be a different question. And we also have to remember here, like this quantity is being taken to an exponent. So if I would put a 2 there, I'd get an x squared. So 4 and 2 and 3 would be 9. So just watch what that's asking for. Not a difficult question as long as you know what it's asking for. Last slide here for today. Want to have plenty of time for you to work. How many distinct zeros does the following polynomial function have? Well, I have a 0 at 5. It has a multiplicity of 4. I have a 0 at negative 6. That has a multiplicity of 1. I have a 0 at 3 with a multiplicity of 1. But it says how many distinct zeros does it have? Well, even though I have a multiplicity of 4 at the 0 of 5, those basically it's like a repeat of that same exact 0. I still only have 3 distinct. I have one at 5, I have one at negative 6, and I have a root at 3. Remember, it's technically like I have a repeated root is basically what multiplicity means. A repeated root 4 times at 5, but when I'm counting the distinct, I'm counting I have 1, 2, 3 distinct real zeros. So these are not real difficult questions to answer, just knowing what it's asking you. I feel like I keep preaching this, but last one. How many distinct real zeros does the following polynomial have? Well, you know what? It's not factored for us. Okay. So if I try to factor that, so numbers that multiply to 45 but add to negative 4, negative 9, and positive 5, not too difficult to factor. But I get a 0 at 9, I get a 0 at negative 5. It says how many are there? There's 2. 1 at 5, 1 at negative 5, I'm sorry, and 1 at 9. But we had to think about how that would get factored. Okay. So I want you to go ahead and begin working either at your Khan Academy assignments or those 5 Get More Math points, just practicing some of that terminology here.